energetic, joshful physics enthusiasts. Now, the NSEP 2024 paper happened a few months back, and there were many messages I received on Telegram कि sir आप उसको solve कर दो. And I replied saying, internet is flooded with solutions, so what do you want me to do? And many students replied back saying, sir आपके solutions बहुत simple होते हैं. So why don't you start solving this paper so that we can get more insights into the paper pattern, and also maybe we'll learn more concepts along the way. So this series is the second in that part. So my name is Bhavdeep Sethi, and I have been converting a lot of physics haters into physics lovers. I speak less about myself and I would speak more about physics. So thank you for joining the session, by the way. Now, one thing you should never expect in this session is the spoon feeding. So do not expect that I'll be giving you the question and the whole solution for that. So that's called spoon feeding. And obviously the internet is flooded with solutions. If you're looking for solutions, why would you come here, right? So you should come here if you need conceptual clarity, if you need some pointers on how to solve the question, and then you're ready to take the challenge and solve it yourself. So this is no spoon feeding wali class. So starting with the question number 6, because in part 1 we did 5 questions, today we'll do 6th through 10th, so 5 more questions. So the ratio of lengths, radii and Young's moduli of steel to brass in this given figure is alpha, beta, gamma, respectively, the corresponding ratio of the increase in their lengths. Honestly, these type of questions are so easy. I have a temptation to just not even bring it into the session, but since we are doing in sequential order, let's go through that. So we know the Young's modulus is equal to the stress, which is F by A over strain delta L over L. Now, you simplify this, what you get is delta L. So this implies delta L is equal to this length jumps up. So FL over YA. Okay. Saying the ratio of the change in length of the steel to the brass. So force. Steel is taking 50 newtons. Brass is taking only 30 newtons. So the ratio of force is 5 by 3. So I'll plug in 5 by 3 for that. And that actually eliminates these two options. So this cannot be the answer, this cannot be the answer, by the way, right? I'm left with two choices. Now the ratio of the ratio of length is alpha. So I'll put in alpha there. Then Young's modulus is gamma. So I'll put gamma there. Then area, the length radii ratio is beta. So the ratio of area would be beta square. And that is your simple answer. So it looks like option number B matches 5 alpha, 3 alpha, beta square. Very easy question. So let's move on to the next one. This is a beautiful question, by the way. So the fuse in the upper branch of the circuit shown is an ideal 4 amperes of fuse. The fuse has zero resistance as long as the current through it remains less than 4 amperes. So as long as the current is less than 4 amperes, fuse is a perfect conductor. The fuse blows out when the current reaches 4 amperes. Needless to say that the resistance becomes infinite after that. Obviously, infinite as in it just blows away. It's an open circuit now. Switch S is closed at time t equals 0. The fuse blows out at what time? Beautiful question. So as soon as you turn this on, see when the switch was off, so there was no current in there. As soon as you turn it on, there's a tendency of current to flow. This has inertia. It says, no, I'll not let the current flow. It will have a back EMF. But as the time passes, it starts giving up and more and more and more current flows through that. And when the current grows to 4 amperes, this fuse will blow. And they're saying, how long will it take for that? Using Kirchhoff's law, if I start from here, I say positive 10, right? So if I start from here, I'm going from low potential to high potential, positive 10, Kirchhoff's loop law. Then there's nothing happening here because of the reason it says there's no resistance as long as it doesn't burn. So 10, nothing happens. Then minus L di by dt. So I can say 10 minus L is given to me, isn't it? Or L is given as 5 Henry. So why would I not put that? So minus 5 di by dt. So this, we are back. So this should be 0. Solve this. So di by dt is equal to 2. Right. You take it on the other side, you get di is equal to 2 dt. Now you integrate from the limits from 0 to 4, isn't it? Because you are starting with 0 amperes, you want to reach to the 4 amperes. Integrate this from 0 to t, and you have to find t. Now I don't really have to tell you, this is 4 is equal to 2t. So t is 2 seconds. As simple as that. So the next question here is, again, I love this question. So a bent wire, this is a wire, it is bent like this, and this is 60 degrees, this is 60 degrees, it is bent like this, and it lies in a uniform magnetic field. It says the bent wire is shown in figure lies in uniform magnetic field B given by 3I plus 4K Tesla. So 3I as in magnetic field this way and 4K Tesla, right? The direction K being normal to the plane of the paper and directed outwards. That's a standard, right, Cartesian coordinate. The two straight sections PQ and QR of the wire each are 2 meters. So basically this is 2 meters and this is also 2 meters. So both of them are 2 meters. And the wire carries a current of 2.5 amperes. The net force on the wire due to the magnetic field B is. Now the problem is many students who don't go conceptually, they would have not understood the fact that this can be treated as an equivalent wire of this. The equivalent length of this can be treated like this. And why did I do that? First, let's understand conceptually, because if I do that, I know this magnetic field of 3I is not going to affect it because that's parallel to that. And the only effect will be from this, and we can see that mathematically also. Logically, this magnetic field in this direction cannot affect a wire that is carrying the current in the same direction. Now this is 2, this is 2, now this is 60, 60, this is 60, this is an equilateral triangle, so this is also 2. So the length is 2I. Now how much is the force? The force would be the current times length cross the magnetic field. Where length is a vector, magnetic field is also a vector. The current is a scalar quantity. Current is 2.5. Now how much is this length? This is 2I. This is 2I. So I'll put it as 2I cross B. Now what is B? B in this case is 3I plus 4K. 3I plus 4K. Now see how if you multiply this, 2I, 3I, I cross I, 0. But I cross K should be negative J. So this is negative 8J. Negative 8J times 2.5 is negative 20J. So negative 20J newtons is your answer. It's as simple as that. Now these kind of questions at the first look, they would seem like these are challenging and there might be a tendency to skip these questions for a later time. But they are honestly, they're very, very easy. Okay. So the next question here. A charged spherical capacity consists of two concentric spherical shells. So there are two concentric shells of radii A and B, where B is the bigger one. Half of the stored electric energy of the system lies within a spherical region of radius r, if that r is this. So here there are multiple concepts coming into play. So let's go by one. First of all, if there is this is A and this is B. So capacity of this is given by 1 by K AB over B minus A, right? Bigger minus smaller one. So that's the capacity here. Now, if that is the capacity, how much is the energy? Energy is So what have they given? They have given, let's take it as charge. Some charge was given to this. So Q square by 2C. So the energy here, energy, or let's write it as U as in potential energy. E might be confusing with the electric field. So U is equal to Q square by 2C by 2C. So C, this will go up. So this will become K. And then when you flip that, you get 1 by A by 1 by B, 1 by A minus 1 by B. So this is the energy that is stored in this capacitor. Now they're saying half of the energy is stored up to some radius here, up to some radius here. So half of the energy is stored up to that radius, and you have to find that radius as a and B relation kind of. Now energy, as we know, can also be found by saying half epsilon naught, or actually, why am I writing E? I don't know why. So energy is equal to half epsilon naught electric field square, isn't it? Half epsilon naught electric field square. Now, but then you have to realize the electric field is varying in this case. Now this charge will not have any electric field. Inside charge, so let's say this was plus Q and this was minus Q. This minus Q has no electric field, sorry, and this inner shell's charge will have electric field, but that electric field keeps varying. And using the shell theorem, you can say electric field is K Q by distance square. So if you take some position somewhere there at a distance of x from the center, the electric field will be KQ by x square. So at some intermediary position there, the energy density, this is energy density as in energy per unit of volume, is going to be half epsilon naught KQ by x square. So this is the kind of electric field square. So this is the energy density as in energy per unit of volume. So this is not energy, this is energy density. So how much will be the energy? Energy will be this times the volume of that elementary shell that you take at a distance of x and thickness dx. I mean, these are the very basic things that you would know. So if you take at a distance of x very elementary, very thin shell of radius x and thickness dx, the volume of that would be 4 pi x squared dx. So this is the electric, oh sorry, this is the potential energy for that shell, but you're not looking for that. You're looking for the entire energy from A all the way to R. So you'll say, okay, the total energy is from A to R. So this is the energy that is stored there, but they're saying that should be half of the total energy. So that should be half of this. So you can simply say is equal to half times, and then you take this energy and plug it in here, and then you solve for R. It is very simple question, and if I remember correctly, you will get answer as C. Again, no spoon feeding wali class. I have given you the pointers, I have told you the concept to use here. Try to solve it out and let's see what you get. Post the in the comment section, you can post the solution maybe. Or you can connect with me on Telegram and you can send me the solution on my Telegram ID. I will reply you back. I promise that. Okay. The last question for today's session, 10th question is two stars of masses, mass 1 as m of s and 15 m of s, where ms is the mass of sun. So there are two stars, one is equal to the mass of the sun, the other one is 15 times as heavy, form a binary system. The stars are revolving around each other, always being at the separation of d is equal to 4 astronomical units. So where 1 AU is the distance between Earth and the sun. Now they move in circular orbits about their center of mass. The period of revolution of the star is, now again, you have to do your own derivations, but I'll tell you what you will get is, let's say there is star 1 of mass 1 and there's another star of mass 2 and they are tangled up and they're revolving around each other because of the centripetal forces, the time period, and again, this derivation is very beautiful and very easy, try to do that, is given by 2 pi, the distance cubed, where distance is distance between them, divided by g. I'll actually write it more legible here. So the time period is given by 2 pi square root of distance square, where distance is the distance between those two masses, divided by this gravitational constant, then the sum of the masses. So this is the time period. So for the given situation, how much will be the time period? So the time period that we are interested in is 2 pi square root of square root of so the distance between them is 4 4 AU cubed. So that gives you 64 AU cubed. 64 AU cubed, right? That's the distance cube. Divided by G times mass of Sun plus 15 mass of Sun. So remember that the masses have to be added up. So I'm mass of Sun plus, now this gives you 16 mass of Sun. So let's erase this out and say 16. So 16 mass of Sun. Now 16 and 64 cross out as 4, and that 4 comes out. So the time period is coming out to be that 4 comes out as 2 times, let's put everything else in the bracket, 2 pi root of AU cubed divided by G ms. Now what is all this? So think about this mass, ms is the mass of the Sun. AU is the distance between the Sun and the Earth. Now if this were the Sun, let's say this is the Sun and this is the Earth, let's say. The distance is AU, right? This distance is AU and this is basically mass of Sun, and let's say this is mass of Earth. Right? So they're tangled up together, they are revolving around each other. So how much is the time period for that? The time period is equal to 2 pi root of the distance cube, which is AU cubed, divided by G mass of Sun plus mass of Earth. Now come on, this is mass of Earth. Mass of Earth is negligible compared to the mass of the Sun. So this can be taken as approximately mass of the Sun. So what is the time period of all this? The time period is 2 pi AU cube divided by G times mass of the Sun, and that is 1 year. Earth takes 1 year. That is the definition of 1 year. So this is 1 year, this is 1 year. So that is 2 times 1 year. That is 2 years. So those binary stars will have a time period of 2 years. And again, look at the question here. In the first look, there is a tendency of thinking that this question is very difficult and let me do it at a later point of time. But these are the questions that you can really solve within 1 to 2 minutes. Rather, I would say 90 seconds should be your limit to do this. I'm explaining you, and that is why it is taking a little longer. But if all you have to do is scribble and come up with the answer, 90 seconds should be the limit for this. Now, by the way, if you want to, if you're targeting NSEP 2025 and would like to enroll in our paid courses, then there's a good news here. I'm starting module 1 of 2025 NSEP course on February 3rd. So it's launching on 3rd of February. The classes will be Monday, Wednesday, 6 to 7 p.m. And this is going to be the scheduled classes, but you will have more classes which are obviously extra classes. Then you get Sunday tests, then assignments, then you get Telegram doubt support, a lot of things, and we'll talk about it very soon. But this is the course that is starting. The link is below. You can enroll for that clicking on the link. The price for one module is 3,000. Total, there are 5 modules in the entire course. So 3 times 5 is 15,000, but we'll give you a discount if you buy the entire course. So 13,500. Now again, for any of these prices, you can use my coupon code Bhavdeep Sethi is my name. So BS Pro 1, and the coupon is already inbuilt in the link below. So apply that, you get 3,000, 10% off, 2,700 maybe. And then even this can be clubbed with the coupon code. Now the modules look something like this. So this is all 11th portion. This is all 12th portion. Module 1 is all mathematical tools, motion in a straight line, motion in a plane, relative motion, laws of motion, friction. And we continue and we target to complete the course by October. So that November we do full revision, sample papers and mock papers and a lot of things over there. So join this Telegram for any practice material that you would need. So a lot of practice material comes on this, and I encourage everybody to keep up the high josh and high energy and keep coming to this YouTube channel. Subscribe to that, share it with your friends, and I'll see you soon. Thank you so much. Bye bye.